So Laurent, for instance, is in charge of the UHV tunnel. We can connect different experiments with a big tube which is in the vacuum. One of the problems of surface science is that we study the surface itself, not the bulk. And the surface is exposed to the air and to the chemicals. If I take one point in that room, the tip of a needle, for instance, but it can be any spot, how many collisions per second it has received?
A lot.
Good answer. How much? Do you have an idea?
Thousands?
Thousands, millions, billions?
Millions?
10 to the 9. So it's
Billions.
Billions.
billions. So it means that in a billionth of a second, because you can put the same arguing with every atom, sort of the surface. So in 1 billionth of a second, if it's reactive, it's covered. So you can stop working. So it's not such a long time to make an experiment. So that's why we need a vacuum which is at least 1 billionth of an atmosphere. Then you have 1 second to work, which is still not good. So you add another 3 or 4 orders of magnitude, and then you can work for an hour. So the idea is that we can transfer samples from different places. That's where all the experiments here are connected to this tunnel. And this tunnel has just a little tray. So we can put the samples on the train and put the train to the next station. Where is it?
Oh yeah.
Yes, you can see the train. It's here, I would say. So you put the sample on it. On the, so it probably has. You can see from here. You can take with this. The problem of the vacuum is that there's a enormous force to fight against vacuum because it's atmospheric pressure. I have an idea about what is the force of the atmospheric pressure? 1 kilogram per square centimeter. So it means that if you have something that big, it's about 20 centimeters, it's on the order of 200 kilograms. It would not be possible to hold anything. So the way we transfer movement usually is through magnetic. You have a magnet, an iron, and then you transfer the force from the outside to the inside without too much effort. Oops. Okay, so now we go to my experiment. Iron source. Here I put again some gas so that the electrons, iron is an atom from which you removed an electron. The nice thing about that is that you can accelerate because it's sensitive to the field, because it's charged. So I accelerate it to the desired voltage, for instance 1000 volts. But since I did neutrals, I have to give it back an electron, and I do it by putting some gas and some collision. That's my specialty, collision physics. And then from there on, I have an atom beam, and I put small hole. I force it to small holes so that I have a good direction. Now I enter the UHV. On top of that manipulator, I have the sample. I orient the crystal, and those atoms that bounce on the surface, they are detected here on a position sensitive detector. It's made of 1 MCP, a phosphor screen, and I image it with the camera. The other option to make a movement, it is not magnetic. This can resist, it's metal, it's complex, but it's thin slices of metal that allows you to have some movement. But still, this one is something like probably 100 kilograms if you would like to, so nobody does it by hand. You have the multiplication so that you can afford, but otherwise you will get inside.